Welcome back to Build Mystery. Today, we're about to witness an incredible boat building project. With nothing more than a stack of wooden sheets, basic tools, and pure determination, one skilled craftsman begins building a full-size yacht completely from scratch. It's the kind of project that most people would never even think about taking on alone. The wooden sheets form the base structure that will later support a mold built from multiple layers of composite materials. But before any of that happens, every single sheet has to be measured, cut, and assembled with extreme accuracy. Even the smallest mistake at this stage could affect the entire hull. Which is why this work demands real experience and precision. After the frame is assembled, every joint is carefully sanded until perfectly smooth. A layer of mold release wax is then applied over the entire surface. This important step ensures that once the fiberglass hull is finished, it can be separated cleanly from the mold without damaging either surface. Next, a coat of primer is brushed onto the wood. It soaks deep into the grain, filling tiny pores and imperfections while creating a smooth foundation for the fiberglass layers that come next. Now it's time for one of the most important stages. A large sheet of fiberglass cloth is carefully laid over the mold. This finished shell is capable of carrying heavy loads while standing up to constant water pressure, rough weather, and years of demanding marine use. With the base complete, construction continues upward as additional fiberglass panels are installed along both sides to create the walls of the hull. Every panel is positioned carefully before the extra material is trimmed away. This isn't just done for appearance. Giving the hull the correct proportions also improves its balance, stability, and overall performance once it enters the water. To strengthen the structure even further, rows of half-cut plastic pipes are bonded along the inside walls using fiberglass and epoxy. Although the technique looks simple, it provides excellent reinforcement by spreading stress evenly across the hull while preventing the walls from flexing under heavy pressure. After the reinforcement is complete, the builder places a long straight pipe along the top edge of the hull to mark the final trim line. Every wall is then cut to exactly the same height. Maintaining perfect symmetry at this stage is extremely important because even small differences could affect how the boat floats and performs later. With the interior work finished for now, a hydraulic jack is used to carefully flip the entire hull upside down. This allows the builder to begin working on the exterior. The temporary wooden boards underneath have now completed their purpose and are removed one by one. They successfully served as the original mold that shaped the fiberglass hull during construction. An orbital sander is then moved across the entire surface, removing every rough spot and preparing the hull for paint. Once the sanding is complete, the hull receives a deep, dark red marine coating. This paint does far more than improve appearance. It helps resist marine growth, protects the surface from constant exposure to water, hides grease and dirt. And also makes the vessel more visible during navigation. The builder intentionally leaves the rear underside of the hull unfinished because this section requires a completely separate construction process. He begins building another mold that will eventually become the tunnel hull, a specially designed recessed cavity beneath the stern that houses the propeller shaft and the surrounding pipe system. Building this section separately allows every curve, angle, and measurement to be adjusted with precision before it becomes a permanent part of the main hull. The next stage follows almost the same process as before. Fresh wooden sheets are carefully measured, cut, and joined together to create another mold. Once the shape is complete, a generous layer of mold release wax is spread across the surface, followed by primer to seal the wood and prepare it for fiberglass. With the mold ready, layers of fiberglass cloth and epoxy resin are applied one after another. As the resin hardens, the entire structure becomes a single solid piece, accurately holding the curved shape needed for the tunnel hull. This tunnel section performs a very important job. It keeps the propeller fully submerged at the correct depth, allowing it to produce maximum thrust while improving fuel efficiency. At the same time, it acts as a protective housing, reducing the risk of damage from rocks, floating debris, or shallow water. Several heavy-duty mounting bolts are installed into the stern section before assembly. These bolts will permanently secure the tunnel hull to the main boat once both sections are joined together. Multiple holes are then drilled through the structure, so the required pipes can pass through without obstruction. Strong mounting clips are installed inside to keep every pipe firmly locked in place and prevent movement while the boat is operating. Before anything is permanently attached, the builder carefully positions the tunnel hull against the main hull and checks the alignment from every angle. Every opening, edge, and mounting point must line up perfectly. Once everything fits exactly as planned, the hollow spaces inside the structure are filled where required and sealed with a top cover, transforming the entire section into one rigid and durable unit. The surface is then sanded until perfectly smooth, before receiving the same paint finish used on the rest of the hull. While the paint dries, the main hull is flipped back into its normal position and raised off the ground to prepare for final assembly. The completed tunnel hull is carefully moved into position beneath the stern and aligned with the rear deck. Steel spacer plates are installed between both sections at carefully measured intervals. These plates maintain an even gap throughout the joint, ensuring both components remain perfectly level before being permanently connected. Long threaded steel rods are passed through both structures and tightened with heavy-duty nuts. As each nut is tightened, the two sections are gradually pulled together into one solid assembly. This method spreads the load evenly across the entire joint instead of concentrating stress in one location, greatly reducing the chances of cracks or structural movement when the boat faces rough water. Although the hull now looks complete from the outside, it is still only a hollow fiberglass shell. On its own, a hollow shell simply isn't strong enough to survive the demanding conditions of open water. That means the next stage focuses entirely on reinforcement. Long wooden planks are positioned along the gunnels, the upper edges of the hull walls. To secure them, bolts are drilled completely through the wooden plank, the fiberglass wall, and another matching plank placed on the opposite side. This creates a sandwich-like structure with the fiberglass locked tightly between two layers of wood. Once every bolt has been tightened, the excess threaded ends are trimmed away, leaving a clean and professional finish. This reinforcement method dramatically increases the hull's overall rigidity, allowing it to resist twisting and flexing under heavy loads. Next, precisely cut wooden boards are installed across the top of the gunnels and secured with nails into the supporting planks below. After every section is in place, the entire wooden surface is sanded smooth, giving the boat a seamless finish that looks as though it was built from a single piece. Attention now moves inside the hull. A series of strong wooden crossbeams are installed from one side of the boat to the other. Every beam is securely bolted into both hull walls, creating the structural framework that will later support the deck floor and everything installed above it. To improve safety, strong metal grab handles are mounted along both sides of the gunnel. These handles provide passengers with a firm grip whenever the boat encounters rough waves or sudden movement. Work then shifts back to the stern. A steel pipe is carefully welded into the tunnel hole, forming the upper housing for the propeller shaft. This is the exact point where the rotating shaft enters the boat before connecting to the drivetrain inside. The quality of this weld is absolutely critical because it must withstand continuous engine torque, along with the constant vibration produced by the spinning propeller shaft. With that completed, the builder fabricates a heavy-duty mounting frame using both wood and steel. This custom-built frame is designed to support the engine and gearbox while keeping both perfectly aligned inside the hull. Even the smallest alignment error at this stage could cause vibration, increased wear, or serious mechanical failure later, making accuracy absolutely essential. With the hull structure now fully reinforced, it's finally time to install the heart of the yacht. But before the engine can go in, the drivetrain has to be built with absolute precision. If even one component is slightly out of alignment, it can lead to excessive vibration, faster wear, and serious mechanical problems once the boat is out on the water. If you're enjoying this incredible build so far, don't forget to like, subscribe, and share. Your support helps the channel continue bringing you amazing engineering projects like this. And if you're passionate about boats, make sure to check out the Nasatchannel as well. He's an experienced boat builder whose channel is filled with impressive custom projects just like this one. The builder now moves over to the lathe, where he machines a custom propeller shaft completely from scratch. Every cut is made with precision until the shaft reaches the exact dimensions needed to connect the propeller directly to the gearbox. Manufacturing the shaft by hand gives him complete control over its size, strength, and final fit. Building a yacht like this also involves a huge amount of welding. Throughout the process, proper safety equipment is essential. High temperatures, sparks, and molten metal make protective gear a necessity rather than an option. Every weld must be completed carefully to ensure maximum strength and long-term reliability. Once machining is complete, the finished shaft is thoroughly lubricated before being carefully inserted into its housing. Proper lubrication reduces friction, minimizes wear, and allows the shaft to rotate smoothly even under heavy engine loads. With the shaft securely installed, the propeller is mounted onto its end, completing the main drivetrain assembly. Every component must remain perfectly centered because even the slightest imbalance can create powerful vibrations while the propeller spins at high speed. The builder then fabricates a heavy-duty bearing joint that acts as the coupler between the propeller shaft and the gearbox. This small but extremely important component transfers rotational power directly from the engine to the propeller. While keeping the entire drivetrain running smoothly. Next, a flanged universal joint coupling is installed onto the gearbox output shaft. It is securely bolted into place, allowing power to pass efficiently from the gearbox to the propeller shaft, while still accommodating slight angular movement between both components. This flexibility helps protect the drivetrain from unnecessary stress during operation. The gearbox is lowered into position first and firmly secured onto the custom mounting frame. Once it is perfectly aligned, the diesel engine is carefully placed directly behind it. The alignment between these two components is checked repeatedly before installation continues. After confirming that everything lines up correctly, both the engine and gearbox are permanently secured to the mounting frame. Locking both units firmly in place prevents unwanted movement during operation. Before the engine reaches its final position, thick rubber dampeners are installed beneath its mounting points. These dampeners absorb engine vibration and stop those constant vibrations from being transferred directly into the fiberglass hull. The rubber element is positioned between two heavy metal flanges, acting as a flexible cushion. Without this protection, continuous engine vibration could eventually crack the gearbox housing or wear down internal gears over time. These dampeners also compensate for very small alignment differences between the engine and gearbox shafts, something that is almost impossible to eliminate completely in a custom-built installation. Attention now shifts to the cooling system. A custom-made seacock strainer is installed beneath the hull. This perforated metal fitting allows seawater to enter the engine's cooling system while preventing weeds, sand, shells, and floating debris from reaching the water pump. Instead of purchasing a ready-made part, the builder manufactures the entire strainer himself on the lathe. Every surface is carefully turned, drilled, and machined until it matches the hull opening perfectly. This ensures a watertight fit while maintaining unrestricted water flow. To complete the cooling system, a water pump is installed and connected directly to the engine. As the engine runs, it drives the pump, continuously circulating cooling water throughout the system to maintain safe operating temperatures. Next, another steel frame is fabricated to support a coolant heat exchanger positioned above the engine. Every cooling pipe coming from both the water pump and the engine is carefully connected to this unit, creating a complete circulation system capable of removing excess heat during operation. With cooling complete, attention turns to the exhaust. A custom exhaust pipe system is fabricated to safely carry engine gases outside the boat. Without a properly designed exhaust system, dangerous fumes would quickly build up inside the enclosed areas of the vessel, creating a serious safety hazard. If you've stayed with us this far, you're clearly someone who enjoys incredible engineering projects like this. Be sure to subscribe so you don't miss our next build. Now comes one of the most interesting upgrades of the entire project. Another drive coupling is installed, but this one serves a completely different purpose. Instead of connecting only the diesel engine, it also links a powerful 13 kilowatt three-phase electric motor into the drivetrain. Rather than operating as two completely separate systems, the electric motor and diesel engine work together through the same gearbox. During slow-speed cruising, the electric motor alone can drive the propeller, providing smooth, quiet, and highly efficient movement across the water. Whenever greater speed or longer travel is required, the diesel engine takes over and provides the additional power needed for demanding conditions. Even more impressively, while the diesel engine is running, the electric motor automatically switches roles and begins operating as a generator, recharging the onboard batteries and preparing them for the next period of electric-only operation. This hybrid setup dramatically reduces daily operating costs because the diesel engine only runs when higher power is actually required. The result is lower fuel consumption, quieter cruising, and far greater overall efficiency without sacrificing performance. To make this hybrid system work properly, the builder machines another custom flange. Unlike the previous one, this flange is designed to connect not only with the propeller shaft, but also with the electric motor. Every surface is carefully machined to ensure a perfect fit, allowing power to flow smoothly through the entire drivetrain without unnecessary vibration or energy loss. Once the flange is complete, the electric motor is connected to the rest of the drive system. Since it's a three-phase motor, it requires a dedicated motor controller to regulate both power delivery and motor speed. With all the drivetrain components finally installed, the builder starts the engine for the very first time. The engine fires up smoothly, and every rotating component operates exactly as intended. This successful startup confirms that the alignment, coupling, cooling system, and drivetrain have all been assembled correctly. Now the project enters its final stage. The first task is strengthening the bow of the boat. A heavy-duty metal plate is positioned at the front and secured using long bolts that pass directly into the internal structure of the hull. This reinforcement is especially important because the bow experiences the greatest impact every time the boat cuts through waves or makes contact with floating objects. Adding extra strength here greatly improves durability and helps prevent future damage. Next, work begins on the upper structure of the yacht. A strong framework is built across the top of the hull, closing the large open section that has remained exposed throughout construction. This framework will support the roof and provide additional structural strength for the entire boat. Inside the hull, several sealed liquid containers are installed between the cross beams. Although they may look simple, they perform an extremely important safety function. The inside surfaces of the hull are then covered with additional layers of fiberglass. Besides creating a cleaner finish, these layers completely seal the interior, protecting the wooden components from moisture while increasing the overall strength of the structure. With the interior completed, the seating system is installed. Once every seat is securely mounted, the entire yacht receives another careful inspection before moving on to the finishing stage. A fresh coat of primer is applied across the entire exterior. After the primer cures properly, the boat receives its final blue paint finish. The bright blue color doesn't just improve appearance. High visibility colors make boats easier to spot from long distances, helping other vessels, rescue teams, and coast guards identify them more quickly during both normal navigation and emergency situations. Attention now shifts to the deck floor. A durable gray rubber mat is carefully laid across the entire walking surface. Every section is pressed firmly into place and trimmed neatly around the edges. Besides giving the interior a cleaner appearance, the rubber surface provides extra grip, reducing the risk of slipping whenever the deck becomes wet. With the mechanical work complete, the builder now focuses on the electrical system. Wiring is carefully routed throughout the boat before being connected to both the engine throttle lever and the gear selector. These controls allow the operator to manage the engine's power and the boat's direction from a single driving position, making operation both simple and efficient. A pressure gauge is then mounted alongside the remaining control instruments. Placing it directly within the driver's line of sight allows any sudden pressure drop to be noticed immediately. In many cases, this simple gauge provides the earliest warning of a developing engine problem before serious damage occurs. Next comes the steering system. A compact steering gearbox is installed beneath the helm. A classic stainless steel ship's wheel is mounted firmly onto the dashboard, becoming the primary control point for steering the yacht. A reinforced rubber steering hose protects the steering cable while guiding it safely along the deck toward the rear of the boat. Finally, the rudder is installed beneath the stern. Once connected, every movement of the steering wheel is transferred directly to the rudder, allowing the yacht to change direction smoothly and accurately while moving through the water. With the driver's seat now installed and every major system fully assembled, this incredible hand-built yacht is finally ready for its first launch. Months of careful planning, precise engineering, and skilled craftsmanship have all led to this moment. Before taking it out onto the water, let's take one final look at the completed build. Every section, from the fiberglass hull to the hybrid drivetrain, has been built with remarkable attention to detail. Now it's time for the real test. Let's see how this incredible yacht performs out on the water. If you enjoyed watching this amazing project, let us know your thoughts in the comments below. We'd love to hear what impressed you the most. And if you're a true boat enthusiast, don't forget to visit the Nasatchannel for even more incredible custom boat builds and engineering projects. As always, thank you for watching Build Mystery. Don't forget to like, share, and subscribe for more amazing construction and engineering videos. We'll see you in the next one.